Welcome to 4.3 linear functions, graphs, and slopes. So, get into the definitions here. A linear function is any function that can be described as f of x equals mx plus b. And this is said to be in the slope-intercept form of the line. Now, some of you might be familiar with y equals mx plus b. Well, this f of x equals mx plus b is really no different than our y equals mx plus b, that slope-intercept form of the line. Just down here we're using function notation, and up here we're not using function notation. So a couple things. Why we call it the slope-intercept form is because this b gives us the y-coordinate of the y-intercept. So notice, the y-intercept of the graph f of x equals mx plus b is the point 0, comma b. So notice, if we have this as our equation, and we want to find the y-intercept, the y-intercept is where x equals 0. We can plug this into our equation over here. We get y equals m times 0 plus b. 0 times m is 0, so you get y equals b. So notice that this linear equation over here and this linear function down here both have the y-intercept 0, comma b, and that's what this is saying right there. Okay, now the slope of the line, so in the form of the line we have here, this m right here and this m right there, that denotes what the slope is. And slope is really telling us about the steepness or pitch of a particular line. So a lot of people that have studied this before talk about slope as being rise over run. So rise is how much we're going over, run is how much rise is how much we're going up, run is how much we're going over. So we can think about a couple things. Let me talk to you about this. We'll come up here for this. So if we think about it, like we could have a couple different lines. So we could have this line, or we could have this line, and then we could have like this line, and we could have that line. Okay, so looking at the graphs right here and looking at the graphs right here, like the red line and the blue line both are said to have a positive slope, and the reason being is as we read from left to right, and that's the way we always do it in mathematics, the y values are going up, or the lines are increasing. So as we read from left to right, these lines are going up. Now these have negative slopes. So these over here have positive slopes because they're increasing. These have negative slopes because they're decreasing. Because as we're reading from left to right, the red line is going down and the blue line is going down. Now, if we look back over here, the blue line is steeper than the red line. So when we think about like how much we go over versus how much we go up, over there compared to how much we go over versus how much we go up, those ratios, we're going up more in the blue line. That's our rise. And we're going over more in the red line, so that's our run. So the blue line is going to have a greater slope, a larger numerical value. Same thing kind of over here. The red line, it's going to have a negative slope because it's going down. This blue line is going to have a negative slope because it's going down. But this is going to be a more negative number. So this could be like -6, where this is maybe -4. Like right here, this could be maybe 1/2. This is going to have to be more than a half. So just those are a couple things that we want to keep in mind as we're thinking about slope. Now, get away. Okay. So, getting back to slope is this notion of rise over run. We have this line right here, and notice we have we pick this point here and we pick this point here. Now we're running 6, we're rising 12. 12 our rise over 6 our run is going to give us a slope of 2. Now notice, what if we picked this point right here instead, and we went over 2, 3, 4. 1, 2, 3, 4, and then we go up 1, 2, 3, 4, 5, 6, 7, 8. So here, the rise is 8, the run is 4, 8 divided by 4 is 2. So notice, it doesn't really matter what 2 points we pick on the line. If we go over 1, that is if we have a run of 1 and a rise of 2, we're always going to land back on the line. So here, if I go over 1 and up 2, we're back on that line. So slope is independent of point. Now notice, we could try to find the slope of this guy over here. Well, we can think about rise and run. So here, if we start at this y-intercept, that would be our rise. If we think about starting there and going over, that would be our run. Now, one thing is this. If we start up here and we're going down, we're going in a negative y direction, so our rise is negative. So we went from 3 to 0, so our rise would be negative 3. Now our run, because we're going in a positive x direction, is positive, so our run here would be a positive 2. And notice we get that negative 3 halves, and we should notice that as we're reading from left to right, the line's going down, so this should have a negative slope, and it does. So those are some things, hopefully getting you familiar with this notion of slope and the concept of slope. We're going to be investigating it further as we go into the more sections, and I'll talk about how we can use that to graph here, and then we'll expand that out in the next couple sections as well. Okay, so moving down to the problems that we're going to be taking a look at here, we want to find the slope and the y-intercept. Now, this line right here, or this equation, is in y equals mx plus b form, in slope-intercept form. This equation right here is in slope-intercept form, so we can read them right off. Now, this one here and this one here are not. And notice, here the y is isolated, solve for. Here the f of x, which is really our new y, is isolated and solved for. So up here, when we're looking for the slope and the y-intercept, the slope is always associated with the x. So slope, m equals 3/4. Okay, and then this number is the y-coordinate of our y-intercept. So our y-intercept is 0, 2. Now, another reason why we like the slope-intercept form of the line is this. Like, if we're trying to graph a line, it's easy if we have 2 points. And when this is in slope-intercept form, we have 1 point because it gives us the y-intercept. So I'm going to plot that, 0, 2. That's 0, 2. Okay. Now, we can use slope in the context of rise over run to get the next point. So if we go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4, we land on this point right here. Sorry, I'm recording the videos at home and the dogs are getting restless. So at any rate, so we got this point down here, that's our y-intercept. We use the slope as rise over run to go up 3 and over 4 to find a second point. 2 points uniquely determine a line, so we can draw the line that goes right through them. Okay, so this only asks for the slope and the y-intercept, which we have here, but this is another reason why it might be important with graphing. So this problem right here, we've solved for y, or f of x, so this is going to be our slope, or m equals negative 5, and we can always think of negative 5 as negative 5 over 1 if we want to use it as rise over run. The 7 is the y-coordinate of our y-intercept, so our y-intercept here is 0, 7. So once again, if we wanted to graph this line, and it's not asking us to do this, but this is going to be coming up, we go up 1, 2, 3, 4, 5, 6, 7 to this point right here, which is 0, 7. And now we can use this as rise over run. Because we have a negative 5, means we're going down 5. 1, 2, 3, 5. And then over 1, so that right there is another point, going down 5 and over 1. Draw the line that goes through them, and we're good. Okay, so on these last two, in order to determine what the slope and the y-intercept is, what we have to do is we have to isolate the y. So just looking at this first problem, if we're trying to isolate this 3y, we need to isolate the negative 3y, so we need to get rid of the negative, or the 2x, so we can subtract 2x. So they cancel over here. What comes down is our negative 3y equals negative 2x plus 8. Now, this is a negative 2x plus 8. We can't combine these. They're not like terms. This has an x, this doesn't. So then finally, to isolate the y, we're going to divide by negative 3. And when we divide by negative 3, we divide everything by negative 3. So here, negative 3's cancel, we get y equals negative divided by negative is positive, so we have 2/3 x. And then positive divided by negative is negative, so minus 8/3. This is our slope, so m equals 2/3, rising 2, running 3. This right here is the coordinate of our y-intercept, 0, negative 8/3, and we're done. So this last one, once again, it's not, the y is not isolated, so we want to solve for y. So first thing we need to do is get rid of the x, so add 4x. Cancellation here, we get 9y equals 4x. And we'll just leave it at that for the time being. Now we need to divide by 9. 9's cancel, and we get y equals 4 9's x. Now, This has our slope pretty easily to detect because it's right there next to the x, but the y-intercept is the number off to the edge. And up here, why I paused for a minute, is when we have 0 plus 4x, we could write that as 4x plus 0. Then we could have divided it by 9, and we could have this plus 0 right there. You don't need to put that. I mean, this is really the equation, but we can always think of adding plus 0 at the end, which this really tells us that the y-coordinate of the y-intercept is 0. So this goes through 0, 0. That is, this thing goes through the origin. And notice if we plug this into the equation, 0 equals 0, this satisfies the equation, so it's definitely a point on the line. So that's the y-intercept. Now this right here is our slope, m equals 4/9, and we're done. So, yeah, hopefully you understood what I was talking about, and we'll see you next time.